Physics Penguin.
Hello and welcome to Physics Penguin's Guide to Home Electricity. In this video we will be looking at the three-colour wiring system that the UK uses and some of the safety systems that are involved. Let's start with the basics. The UK uses an AC electricity supply that works on a PD of about 230 volts. It doesn't have a plus or minus sign like on a battery, because the current is changing direction from plus to minus and back about 50 times a second. So instead of positive wires and negative wires, we have live wires and neutral wires. Both of these carry current and both can give you a shock. Live wires are brown and neutral wires are blue. Live wires are carrying a varying PD, and the neutral wire should stay at 0 volts. To try and remember the colours, you could use one of these. There's no L in brown, so it's live, and no N in blue, so it's neutral. Or just Joe Brown is a real live wire. Live wires connect to the fuse in an electric plug. Now let's have a look at a diagram of a plug. You have to remember which wire goes where and what the parts all do. So as you can see, let's go at the bottom. The cable has to be firmly held in place, and that's the job of the cable grip. They don't all look like this, there's quite a few designs, but this is the basic principle. The three wires are held together inside some extra plastic insulation until the cable gets way beyond the cord grip. The neutral, blue wire goes left. Blue, second letter L, left. The live wire goes right. Brown, second letter R, right. The fuse comes after the brown wire attaches. This is a special part that contains a thinner piece of wire. If too much current starts to flow, this fuse wire will melt, and that breaks the circuit, stopping any current flowing at all. This is a basic safety system. The final wire is the green and yellow one. This is the earth wire. The earth wire normally does nothing in the circuit. It connects a metal case for your appliance to the earth or the ground. This wire ends up connecting to a cold water system that goes into the ground. This is a route for the current to take if something goes wrong. In this case, the current will probably get quite large, and that will probably melt the fuse and stop the circuit completely. If the electrical appliance does not have a metal case, then it can't be earthed. The case will have this symbol, and the cable will probably only contain live and neutral wires. Electrical circuits in your home work at a high enough PD to do some serious damage to you. You probably use electricity every day, but you will experience a shock very rarely. The system we have is very good and very safe. Please don't mess with electric circuits. Pay particular attention to warning signs. If it says danger, high voltage, it isn't kidding. The reason high voltages, or potential, are dangerous is that electric charge can jump about 1 centimetre in dry air and much further in damp conditions per 1000 volts. You don't have to touch high voltage equipment to get a shock. 230 volts is fairly safe because that could only jump about 2 millimetres, and if you're that close you are practically touching. The power lines outside though can be at hundreds of thousands of volts, and that can jump meters. So be careful. You need to have a look at the question sheet now. Follow the link in the description, pause the video, and then when you've done it, unpause to go over the questions. Okay? Okay, welcome back. Let's go over the answers to the questions. Let's start with question 1. The colours of the wires. You just have to learn them. This is a common question at GCSE. Live is brown, neutral blue, and earth is green and yellow stripes. Question 2 is harder. What does each wire do? Well, live carries current into a device and has a variable AC, PD or voltage. The neutral also carries current but should be at 0 volts PD. The earth wire is a wire to take away current from a metal case in the event of an accident to stop you from getting a shock. Question 3. The earth wire should normally stay at 0 volts. It's connected to the actual earth, as in the planet we live on, and we call that our definition of 0 volts. So question 4 is all about what does a fuse do? Well, a fuse is a thin piece of metal that will melt if the current gets too high. When it melts, the circuit breaks and all current stops. It's a safety feature to prevent overheating. This is why, if a 5 amp fuse keeps blowing, don't just replace it with a 13 amp fuse, because something is wrong and the device could catch fire. Question 5. What happens if a live wire touches an earth wire? Well, note that we mean the copper wires here, not just the plastic insulation. If this happened, the current will miss out the appliance and just go straight to the earth. Because there is very little resistance, the current will be very large and this will melt or blow the fuse. So it's a pretty bad thing. Alright, question 6. What's wrong with all these plugs? Thanks to CRF509, a user on the Times Educational Supplement website, for this image, by the way. The first plug has the cable not held by the cord grip, so we would have to use the grip and tighten it up. The second plug has all the insulation stripped way too far back, exposing the copper wires and allowing them to touch. We'd have to trim off all that excess copper wire, give it a bit of a haircut, and rewire the whole plug. Don't laugh, I've seen plugs wired like this. The third plug has a damaged case. Since we could touch the wires inside the plug, we'll just have to replace the case and rewire. The fourth one looks okay at first glance, but it's a really common and serious error. The cord grip is gripping individual wires and not the outer plastic cord. In use, the wires will get easily pulled out of the plug, causing a possible short circuit as they do. We need to shorten the exposed wire a little and grip the outer cord in the cord grip. And the last one takes a pretty careful look. The live and neutral wires are the wrong way round. Live is brown and should have the fuse next to it. Some simple circuits like light fittings might actually work like this, but it's very unsafe. Well, I think that's it for this week. Well done for getting this far. Subscribe to be alerted of new videos, but for now, stay safe and ta-ta from Physics Penguin.
Physics Penguin.